So in elementary mensuration, we will firstly have areas of triangles, some of the relations that you already know, and some approaches and some results that will be new to you as a class 9 student. Like all of you have gone through Heron's formula while going through triangles. If I think of a triangle, which is a scalene triangle with having side lengths respectively small a, small b and small c units, in that case, we believe the perimeter of the triangle, that is a plus b plus c, denoted as 2a's. Okay, and area of this triangle can be represented as root over s into s minus a into s minus b into s minus c unit square. Here s stands for half of the perimeter or semi perimeter. This particular one is known as Heron's formula. The second result is for an isosceles triangle where the two equal sides are b, whereas the not matching length of base been considered as a. Then we can think of this triangle of area a by 4 into root over b 4b square minus a square. Basically, we can get to area of any triangle as half into base into height, right? So using half into base into height, we can get to the height of this triangle, that is b square minus half of a square, or better to say half of a whole square, that is b square minus a square by 4 is the height. Okay, so when we are plotting it into the area form, we are getting the area of the isosceles triangle as a by 4 into root over 4b square minus a square, where b is the equal sides length. If we get to an equilateral triangle, then due to the same reason, b will be replaced by a. Now all three sides are having length a. So area of such a triangle will be root 3 by 4 into a square unit square. So always remember, when we are going for area, it's square units. Okay. Next, we have considered the general idea of triangle from a right triangle. In a right triangle, the area is simply half into base into height. So if P is the perpendicular and B is base, then half into P into B unit square is the required area. If I consider of such a triangle, ABC, where the angle between AB and BC is theta, in that case, we can think of, if AB is given as L1 and BC is given as L2, then as per the right triangle trigonometry, AD by AB is sine theta, right? Like for any triangle ABC, we can always draw a perpendicular from A to BC, and we have marked the foot of the perpendicular as D. So AD by AB from triangle ADB, this is sine theta, confirming AD as L1 sine theta, and hence area of triangle ABC, that can be written as half into base into height like earlier, as half into AD into BC. That's going to be half L1 L2 sine theta unit square. So that means if you know the two side lengths of a triangle and the angle between the two side lengths, then area of the triangle can be found as half into product of the side lengths into sine of the angle between the two sides. Is this point clear to all? Next, we have gone for a rectangle. So rectangle is of area AB, where A is length and B is breadth. Even you can consider of the right triangle from where we have got this idea of half into base into height. That is basically half of the rectangle described about one diagonal. Okay. Now, if you think of a rectangular page of area AB, and you are keep on such rectangular page one after another, such that after storing such pages, it is creating a notebook of height h. In that case, it will be a cuboid having volume ABH unit cube or ABH cubic unit. Whereas the surface area is going to be, there will be two rectangular surfaces of A into H dimension, two rectangular surfaces of dimension A into B, as well as two rectangular surfaces of dimension B into A. So total surface area for the cuboid is going to be 2 into AB plus BH plus AH, whereas the volume is AB into H. When you store a constant area one after another to achieve certain height, the volume we generate is area into height. Is that okay with everyone? Clear to all? So I'm moving to next section, that is area of a square. We know that if any square having side length A, then its area is going to be A square unit square, right? So if we think of a cube compared to the cuboid, it's going to have volume A cube cubic unit, and the surface area is going to be 6A square unit square, because for cube, the area of each square is A square, which is stored for a height of A, and each of the 6 surfaces having area A square. If we think of a trapezium whose parallel sides are respectively A1 and A2 units, whereas the distance between the parallel sides is H units, then area of the trapezium will be half into H into A1 plus A2. Basically, if we draw a diagonal for this trapezium, it will be splitted into two triangles, each of them of height h, whereas their bases can be considered of length A1 and A2 units respectively, right? So that gives us area of the trapezium half into h into A1 plus A2 unit square. Next, area of parallelogram. If I think of a parallelogram where two adjacent sides having lengths A and B, and the angle between these two sides is theta, then the area of the parallelogram is going to be AB sine theta. And why it will be so? The justification for that coming from this triangle. Just now we have considered if this is L1, this is L2, then area of the triangle is half L1 L2 sine theta. Now if I construct another such triangle joined with that, it will create a parallelogram. Is it okay with everyone? I'm just showing you
Yes,
the
sir.
format in the smaller way. So this is the triangle, and if I have the triangle again, so joining these two, we are going to have a parallelogram like this. So that means a parallelogram with side lengths L1 and L2 and angle between them theta will have area twice of half L1 L2 sine theta, or in simple words L1 L2 L2 sine theta. Is it okay for all? How we are getting double area? So I'm removing this one. Now get back to this. So over here we can consider of firstly area of this triangle, that should be half AB sine theta, and even the triangle over here that will also have the same area, and hence it will be half AB sine theta, adding which we can get to AB sine theta. The alternate description to the same result is this is B, this angle is theta, so this perpendicular length will be B sine theta, right? And hence we are considering of this base as A and this height as B sine theta, giving you the area AB sine theta. And it will be same as the area of the rectangle, because you can think of from this dimension A and B sine theta, if we think of the rectangular formation, I can cut down this part and add it over here, right? So this section, if I cut from this diagram and add it exactly over here, it will be a rectangle of dimension A and B sine theta to generate us this area. If I think of a parallelogram whose diagonals are respectively L1 and L2 units, and the angle between the diagonals is alpha, then by the earlier idea, we know that this point will bisect both the diagonals. Using congruency of triangle, we can establish so. So area of triangle QOR, this QOR, this will have side lengths L1 by 2, this is L2 by 2, and the angle between them alpha. So area will be half into L1 by 2 into L2 by 2 into sine alpha. Whereas angle of, area of triangle QOP will be half into L1 by 2 into L2 by 2 into sine of 180 degree minus alpha, right? So the total area for the parallelogram will be 4 such triangles. As such, for the time being, just follow sine of 180 degree minus alpha is exactly sine alpha. How it happens, we will have it in the trigonometric section. So if sine of 180 degree minus alpha is same as sine alpha, so both these areas are same, and we do have 4 such triangles. So the area of the parallelogram will be 4 times of each triangle, that is half into L1 L2 sine alpha. Is that clear to all? Has everyone followed so far? Now let us consider a rectangular shape where the length is 2 pi r unit and the breadth is h unit. Now if I roll this rectangular sheet in this shape so that this two breadth of length h coincide with each other, in that case this shape will generate a cylinder, a right circular cylinder. What is the area of this rectangular sheet? Can anyone answer?
Sir, 2h pi r.
So 2 pi r into h, that is area of this rectangular sheet. So even after making this right circular cylinder just by folding the sheet in such a way that the two breadth coincides with each other, so curved surface area for a right circular cylinder will also be 2 pi r into h. Moreover, this circular surface of the cylinder will be created by rolling of this length. this particular length will be rolled to create the circumference of the circular surface. So that means the cylinder must have radius r, because this circumference length is 2 pi r. Is that okay with everyone? And we can think of this circular surface of area pi r square that's been stored one after another to create this volume. So that means the volume of the right circular cylinder will be pi r square into h. So first of all, area of circular top or base, that's pi r square unit square, that's for circle. Okay. The curved surface having area 2 pi r into h, that gives us total surface area is addition of these two. Now there are two such surfaces. So 2 pi r h added with 2 pi r square will give us total surface area 2 pi r into r plus h. Whereas we can think of the volume of the cylinder where pi r square area been stored after one after another for a height of h. So volume will be constant area stored into height. Okay. So that's pi r square h. Is this part clear to all? Everyone followed the results? Next, we will have a right circular cone. Now over here, area of the circular base is pi r square. Like earlier, this is also a circular surface with radius r. If I consider the height is h, then the slant height can be found by Pythagoras theorem, that if we denote slant height by L, it is nothing but root over r square plus h square. The area of the curved surface will be pi r into L. The total surface area for this right circular cone will be this pi r L added to the circular surface area. That's pi r square plus pi r L, or pi r into r plus L. And volume of the right circular cone will be 1/3 pi r square h. Now earlier we had pi r square area stored for height h to give us the volume of the cylinder pi r square h. Whenever we will get any such instance where an area is continuously decaying, keeping the shape same, and finally after the same height it's been transformed into one, it will give you 1/3 volume. And why it happens, we will have the justification afterward with the idea of integration. Okay, when we integrate area, we get to volume. So with the ideas of integration, we can justify why a right circular cone will have 1/3 of the volume of a right circular cylinder having same radius for the circular surface and same height. The next step we will consider is a sphere. The surface area of a sphere having radius r is 4 pi r square. Well, if I cut the sphere into equal halves, then each half is called a hemisphere. And due to this cut, what will happen? The curved surface area, which was 4 pi r square for the sphere, for hemisphere, it will be half, that's 2 pi r square. And due to cut, there will be another circular surface of pi r square will be open. So that will make the total surface area for a hemisphere as 3 pi r square. The volume of the sphere will be 4/3 pi r cube, and volume of hemisphere will not have any such other impact, and it will definitely give you the volume 2/3 pi r cube. Is that okay with everyone?
Yes.
The last shape that we will talk about is a
Sir, can you
frustum.
wait 1 second?
I'll show you the notes afterward. Just go to the idea, then I'll
Okay, sir.
definitely allow you to know. The last shape that we will talk about is called a frustum. Now, what is a frustum? Like if you consider a right circular cone, and from this right circular cone, if we cut the cone parallel to base at certain height, then whatever is the residual shape removing the top cone is called a frustum. Okay. So let us consider this frustum where the centers of the circular surfaces are C1 and C2 respectively. The smaller circular surface having radius R1, the greater one with radius R2, and the slant height of the frustum is Bm marked by L1. And let us consider that this frustum been cut from this right circular cone. So if we continue like this, if we have the cut piece and put it over here, we can complete our right circular cone. We have assumed that the height of the right circular cone before the cut was h1. After the cut, we have considered the height h, so we have kept it same here. So that means AC1, this height is h1 minus h, right?
Yes, sir.
So we have gone by this similarity of right triangles like ABC1, this is a right triangle, as well as AMC2, this is also a similar right triangle, right? So from these two similar right triangle, we can have MC2 by BC1 is same as the total height, that is AC2 by AC1. Okay. So from that similarity, what corresponding sides are generating in terms of their ratio gives us R2 by R1 is same as H1 by H1 minus H. From this, we can have cross multiplication to get R2H1 minus R2H is same as R1H. That is R2 minus R1 into H1, taking the terms to this side. R2 minus R1 into H1 is equals to R2H, or H1 been found as R2 by R2 minus R1 times of H. So H1 minus H will be R1 by R2 minus R1 times of H. And with this results, we have gone for volume of the cone with height AC2, that is volume of this bigger right circular cone, that is 1/3 pi R2 square H1, like we have already discussed about cone. And volume of the cone with height AC1, that means the cone to be removed to get to the frustum, that will have 1/3 pi R1 square into H1 minus H. Okay. So volume of frustum, if we use these values H1 in terms of R2 by R2 minus R1 times of H, if I put it over here, and for H1 minus H, if I use R1 by R2 minus R1 times of H over here, so volume of the frustum is first volume minus second volume. Clear? So that's what we are getting as 1/3 pi h into R2 cube minus R1 cube by R2 minus R1. Or performing this ratio, we can have 1/3 pi h into R2 square plus R1 R2 plus R1 square. Is that okay with everyone? This result? Has everyone followed how we have got this result? the curved surface area of the cone with height AC2, that is the greater size cone, is pi r2 into am as slant height. So that can be represented in terms of r2 and h1. So we have got pi r2 squared by r2 minus r1 into root over h squared plus r2 minus r1 whole square as the curved surface area of the greater cone. Whereas curved surface area of the cone with height AC1 can be similarly found in terms of pi r2 into AB, that is pi into r1 square by r2 minus r1 into root over h square plus r2 minus r1 whole square. Now from the greater surface area, greater curved surface area, if I subtract the smaller curved surface area, then we will get to the curved surface area for the first term. Whereas from the first term, we are also getting that h square, this was h, so this is also h square plus r2 minus r1 whole square. This much of length is r2 minus r1, as this complete was r2 and this much is r1. So if I cut equal length of r1 from r2, this much is r2 minus r1. So h square plus r2 minus r1 whole square. By Pythagoras, we can mark it as bm square, that is L1 square. So if I use this expression as L1 square in the second result as well as in the first result, so we can have the result curved surface area of frustum as pi r2 square by r2 minus r1 into L1 minus pi r1 square by r2 minus r1 into L1. That is taking pi L1 common, it's r2 square minus r1 square divided by r2 minus r1, or simply r1 plus r2 we are getting from this ratio. So curved surface area for frustum is pi L1, where L1 is the slant height of frustum, into sum of the radii for the circular surfaces, and hence total surface area of the frustum will be this curved surface area added to this circular surface area and this circular surface area. So when we have added pi r1 square and pi r2 square along with the curved surface area, that gives us the total surface area for a frustum.